Good evening, everybody. Thanks for being here. Um, Probably a lot of you. Good evening, little peeper. Um, hey, Eli. Hello, Tyler. Good evening. I mean, everyone's had a long day by now, no doubt, so thanks for being here. Nijo, good evening. Baby doll, hi. Okay, so week two. Your class, um, I haven't had a day off in a while now, but I'm feeling good about your class because I've created almost all of your content at this point. Um, some of you may have looked around, I'm not sure, but I'm just going to show you some things that I've done since I saw you last. Uh, every bit of your content for the whole semester is now available to you, with the exception of Team Project 2, which version 1 I created and I thought it was probably too difficult to be fun, so I had to scratch it and I have to start over with a different idea. So Team Project 2, my goal is to have that done this week, and then all of your content is available. Team Project 1 is available, and eventually your reminders will in the modules will start calling that to your attention. So anyway, all your content's up through week 17. All of the coding assignments are there. Um, all of that content, all of the projects are there except for Team Project 2. So I'm feeling proud of myself for that because that was a lot of work. What else have I changed? So on the guides page, as I encountered situations where I thought it would be helpful to you to have a guide to perform a task in your REPL, mostly I added a guide. So some of these are not going to be relevant to you until you get later in the semester, and then you'll see references to these guides. But I've added a few guides to the list, so there's a handful of new ones in here you'll see, and these are linked to the labs and the projects that they are relevant to. So just so you know. Um, Okay, so all the modules, and I think we can just go, and we may not even need an hour depending on how productive we are and how many questions you guys have. So um, there have been some people, by the way, who have been active on the Piazza boards, and I very much appreciate everybody who does that. Asking a question is just as good as answering a question on Piazza, because you're giving the group a chance to sort of share our issues and then work toward solutions together. So asking questions is just as good as answering them. And a few people missed this question on the week 0, the orientation quiz, but you don't have to. It's not a test of the discussion. So if you think that you have an idea that might work, you should share it. One reason to do that is because someone will eventually try your idea, and if it works, they'll say, "Hey, it was awesome. Your idea worked," or "it didn't work as we expected," but then everyone will know. So, um, okay. So the question about, do you have to write your code inside of the REPL? No. You can write it wherever. Eventually, you need to paste it in there, but no, you can code wherever you want. You can code on any system, in any tool, Atom, Xcode, whatever. All that's good as long as you paste it and make the REPL project correct, so that when we go to grade it, everything works as expected. So, um, yeah, there's no reason why you have to code inside the REPL, because we don't see that anyway. All we see is the finished product. Okay, so, oh wait, I don't know why I'm going way down here. We're in week 2. Week 2. All right, so I'm sort of stepping through the module just to remind you about what's there and what you'll see. So the goals for this week, week 2, I just sort of leave that every week. I want to make sure that you're aware of the fact that what you should be doing is creating a new REPL project for every new thing that you do. It's a good way to keep a history of the work you've done in the class, but also you don't want to overwrite old work in case a grade gets lost or something happens. So every new project, every new lab assignment, they all get a new REPL. So we're just doing some C++ boot camping for the first few weeks. So We're going to declare variables. We're going to do IO, input and output in C++, and then use uh, branches and loops, decisions and loops in the code. So all of that is just review and boot camping C++. I have 2 chapters for Zybooks listed here. The branches and loops section. So if you're new to C++ or rusty on C++, those are the 2 relevant chapters for this week, the new stuff that's going on. And then I'm just going to go straight into at least giving you some tips for getting started on the lab. So it's a rock paper scissors game. This link here, by the way, is probably, what is this, to Wikipedia? Yeah, it's a Wikipedia entry. So that's just to cover my bases in case someone has some doubts about what I'm referring to, or hasn't heard of that, or has heard of it by a different name. The rock paper scissors game. The reason why programming teachers like rock paper scissors is because it has decision making and looping inside of it. So you have to write a lot of if statements, and you have to have variables, and it's nice that you use random numbers, so you have to do that as well. That's why we like it, is because it kind of forces people who are implementing it to use these standard techniques, loops, if statements, that kind of stuff. But anyway, with that said, I'll just go into the REPL and I'll fire up a little thing and then take some questions. There's not a whole lot of stuff for me to show you in the REPL because it's all pretty basic coding, and a lot of you probably have written a game like this before. But I will do some basic setup for it just so you can, if you have doubts, you'll have a sense of where to go. I do want to show you something that came up in the Zoom meeting last week about reopening an old REPL. So if you're not seeing all of your projects on this home page, if you click on this link over here, My REPLs. Now I've been sort of playing with this just to make examples for people to look at. But this will have your old REPL projects in it. I've created a couple of folders just to put old stuff away inside of it. And then I went in here and I actually implemented our project 3 inside of here just to make sure that it was going to work inside the REPL before I assigned it to you. And then here's the lab 1 from last week. So this is a way you can get back to old REPLs. You can reopen them and continue to work on them if you want. Okay, so I'm going to make a new one. There's also there's a new button over here, and then there's a plus sign. Same thing, I'm sure. Yeah. So pick C++. Replace the weird default name with lab 2. That's what I'm going to be working on here. And then it should open it. And I'll just remind you about a couple of things as I go. So these little buttons over here, the files thing, that just toggles the little file listing on and off. So eventually you're going to start making labs and projects that have multiple files in here, just so you know. So you will be sort of working in here eventually. For now, we're just going to use this one file. The other thing I'll tell you, by the way, is that in Replit, you have to have a file called main.cpp. Replit was set up so that your driver, the file of yours that has int main in it, has to be in main.cpp. Replit won't even let you delete this, I'm pretty sure. Like, it's not even an option, see? It's not an option. I can't rename it. It has to be there, and it needs to have your main in it. So just so you know, that's how REPL's set up. That's always going to be there. This next one is version control. Most of you probably aren't going to use it. Maybe none of you are going to use it, but if you have a GitHub account, you can connect your Replit to your GitHub account, and you can back up your Replit code onto GitHub. That's not a requirement in this class, so just showing that it's there. And then the last button is the settings. And I'll just show you what I'm using. That's not, I think the stacked layout is not the default. I think it's side by side, and That just looks terrible to me. I don't like working with it like that. So I use the stacked layout. Um, for broadcasting purposes, for streaming purposes, um, I've experimented with both light and dark, but when I'm sitting here in front of my laptop, I prefer the light look, so that's why that's there. You can alter the font size inside of the Replit if you want. Hopefully, for your purposes, yeah, hopefully most people can see this size pretty well. Um, the indent type and size, so most of us in programming these days use spaces for indenting and not tabs. Um, Now, when you press a tab, what the editor's going to do is it's going to put two spaces instead of an actual tab character in your code. So most of us, pretty much all of us, use spaces anymore. Some people like indent sizes of 4 spaces and sometimes even 8, but I like 2, and that's probably the default in here, but these are pretty common settings. Keyboard shortcuts. I mean, if you know Emacs or Vim, I know Vim, but I'm not going to use it in this class. Um, and the rest. Anyway, just showing you the settings part to remind you that those are things that you can play with and see if you can find something that you think feels right for you when you're working. So done with that, I'll just bring the file view back up. Okay, so we're on lab 2. It is a rock, paper, scissors game. And I'm going to focus first on, let me undo that. I'm going to focus first on the random number part to try to give you a handle on how to work random numbers. So if you're coming from the Go language, the Go language has some capabilities in its random number generator that makes life a little bit easier, and just a tiny, tiny bit easier than in C++, where you have to know how to do some things manually. But if you're coming from Go, you're also going to recognize some of the same stuff. Okay, so to do random numbers, we're going to have to add an include here. CTime. This is the C in front of it means that this is a C library from the C language that's been made friendly for C++. So if you ever see someone doing an include time.h, that's the old C code style of doing this include. The C++ way of doing that include is CTime. So this is a very sort of Stack Overflowy way to do that, but it looks dated. It's not wrong, it just looks dated. This is kind of the C++ way of including the time library. We use the time for seeding the random number generator, which is the same thing that we do in the Go language, actually. The other thing I'm going to do is I'm going to put a using directive in here. By doing that, I can get rid of this std : and since I'm going to do a lot of cout type statements, that's going to make less typing. Okay, so let's get rid of that. And let's deal with random number generating. So I might have even put this in the discussion prompt. What we're using are called pseudo-random numbers. They're not truly random numbers, and they can't be because they're being produced by an algorithm on a computer. And there's no way to make that truly random. There's just ways to create the illusion of randomness. The best way to get a random number is to go up to a random person and say, hey, tell me a number. That's kind of truly random unless you happen to know the person and know that they always say 13. But in a computer, there's no way to get a truly random number, so there's tricks that we use to try to create the appearance of random numbers. So the way to think about how this works is that the algorithm actually just produces a series of numbers. And it always produces the same series of numbers. It's an algorithm. It produces exactly the same numbers every time. And every time you ask for a random number, you just take the next number in the sequence. That's how to simplify it, but anyway, the way to conceive of how it works is that's how random numbers work. This algorithm starts running, and I ask for a random number, and it gives me the next one in the sequence. And then I ask for another random number, it gives me the next one in the sequence. And if I start at the same place in the sequence every time, I get the same number every time. And I'm going to prove that to you uh, by printing out a few random numbers just to see what those look like. So that's the random function. That will give me a random number, and I'm just going to print 3 of them. This seems like a side trip, but a lot of people don't really know how random number generating works. There are fancier ways than this built-in thing, but hopefully this is going to work. Let's just see if we get 3 numbers. Okay, so they're quite large numbers. You can see them down here in the bottom. But watch what happens when I run this again. So I don't know if you noticed, but it's the same numbers. In fact, let's copy them. I'll just highlight these, Control C. Is that going to let me do it? Can I copy out of this terminal? I can. Okay, there we go. I'm going to copy these. So there's the numbers. That's the sequence of numbers. So the first one I get is this one, the second one I get is this one, and the third one I get is this one. And every time I run it, I get the same sequence every time. And that's because this is where the algorithm starts. That's the start of the sequence. This is the second one in the sequence, the third one in the sequence, and they will always be exactly the same. If you can go to a casino and figure out where their random number generator is starting in the sequence, you can make money. But they go to some trouble to make this more random than what we're doing. Okay, so that's a problem. So the way we get around that problem is we do what's called seeding the random number generator. And what seeding the random number generator does is it places our starting point somewhere in the middle of the sequence, as opposed to the first number in the sequence every time. Seeding the random number generator places our starting point somewhere in this sequence of not truly random numbers. But the point is, as long as we're not starting right at the very beginning every time, then in theory, the random numbers that we pull are going to look different. Now, to make that look really random, what we do is we select a seeding place or a starting place using the system's time. Let's see, do I just want time 0? Technically, that's a null. I wonder if I can just put null. Let's do that. Let's use null pointer. So I'm going to select a starting place in this sequence of numbers that are based on the computer's clock time. And if you think about what the clock time is doing, it's constantly moving. So the clock is constantly ticking. So every time I rerun the program, the clock has moved, and it is giving me a starting place in this sequence that is different from the last time when I started. And what it then does is creates the better appearance of random numbers. So I'm going to run this. So notice that I'm getting different numbers this time. Does this have this feature? Let's see. Sweet. Control /. If you highlight a section, do Control /, it highlights all. So you can see I got a different sequence of numbers, and I'm going to run it again. And I get a different sequence of numbers again. So it's the same algorithm, the random number generator. But because the seed is placing me at a different point in the series of numbers that the algorithm generates, it creates the appearance that I get different numbers. So that's how that works. Okay, so that's part 1. Part 2 is usually, at least in our class, this is null pointer. Yeah, so it's a little bit hard to explain, but we can actually place a variable in here, and the time function will actually populate that variable with data, more specific data about the current clock time, like the hours, minutes, and seconds and stuff. So if I were to put an actual piece of variable in here, I could actually collect the specific data about the current time that the computer reports. If I put null pointer in here, I'm just telling this function time that I don't care about collecting that data into a variable. So that's what that does. Okay, so that's the first part. That was weird. Just how does that random number generator work? So they're not, we call it pseudo-random numbers because it's an algorithm that produces a series of numbers, and we use this little trick of the clock time to just start in different places in the series, which creates the illusion that the numbers are random. But if you were to do something like seed to 99, you'd get the same series of numbers every time. You'd be starting at that place that 99 takes you to. So we use the clock time because that's a moving target, and that makes the numbers appear more random. Okay, so here's the other issue that we need to deal with about random numbers, which is these numbers are way too stinking big. Like in this program, we need numbers, we need the computer to produce randomly one of three options, right? We need the computer to give us only three options, and if these numbers are true, then the computer is generating anywhere from, let's say, 0 all the way up to this number, which is way too many numbers. We just need three. We need the computer to pick 1, 2, or 3, rock, paper, or scissor, and not millions of different options. So the second part of this problem is, how do we turn a giant number, how do we carve it down into the range that we desire? Does anyone know in chat how to do that? There's an arithmetic operator that you can use that, almost like magic, turns a big number into a little number. Mod. Good one, baby doll. It's mod. So the mod operator, if you take mod, and I'm just going to do it. Hold on, I got to fix this. My keyboard is just a rat's nest, and the keys are falling off and stuff, so I got to go and press the delete key down where it's safe to do that without deleting code. Okay, so the mod operator, now its job is to actually calculate the remainder of a division. But it turns out that that remainder is kind of magical. So if I take a giant number, like the numbers I get from Rand, and I do mod 10, because of the way mod works, a number that's evenly divisible by 10, even if it's humongous, like this one down here, is going to return 0. Yeah, good one, little peeper. It is modulo, you're right. If I mod 10 against this giant number that ends with the 0, well, 10 goes evenly into that number, and I'm going to get a 0, like magic. And it turns out that if I mod by 10, the biggest remainder that I can possibly get is 9 on any number of any size. Because if the remainder were 10, that's no longer a remainder. 10 evenly goes into it. So you can sort of quickly see what it would do to these numbers if you understand that. If I mod this value by 10, I'm going to get 3. That's what's left over after I divide out all the 10s. The second number, I'm going to get 6. That's what's left over after I divide out all the 10s. This one will be 7. This one will be 1. This one will be 3. And we can prove that. We'll just mod 10 all of these to show you that this is a really cool trick for taking a big number and fitting it into a range that you want. So the range I can possibly get now is between 0 and 9. So if I mod anything by 10, I'm going to get somewhere between 0 and 9 guaranteed. That's the way the math works. And I can run this and I'll just show you. So I got 5, 0, and 9 that time. That was some large numbers. And when I modded by 10, 5, 0, and 9, 5, 1, and 2. Anyway, I could just keep clicking this all day. 0, 2, and 3. They're pseudo-random, and they're being limited by mod to the range of 0 to 9. So in our program, I don't need these numbers anymore. In our program, we need the computer to pick from 3 options randomly. So the trick is to figure out the mod value for our program so that we get only 3 possible outcomes. And I'll let chat tell me what the mod value would be here so that I'm taking these giant numbers and I'm whittling them down to only 3 possible. 3, good one. Good one, Sloth. 3. So if I mod 3, the only possible results I can get, no matter how big that random number gets, are 0, 1, and 2. Good one, Dice K. Yep, 3. So I'll run that. And you'll see I'm only going to get 0, 1, or 2. I got 1, 0, and 1 that time because they're pseudo-random. You could do that, Baby Doll, if you wanted to. So I'll show hers. So Baby Doll's pointing out another trick that you can do if you want to sort of put it in your comfort zone. If you want those numbers to look like 1, 2, or 3 instead of 0, 1, or 2, you can simply add 1 to it. And now instead of 0, 1, or 2, your range is going to be 1, 2, or 3. Got all 2s that time. So that's great because now it doesn't really matter how big that random number is. I'm going to get one of 3 possibilities randomly, pseudo-randomly. So 2 and a 1 and a 1. All right, so hopefully everyone's sort of tracking that. This is just a really great computer science trick. You're going to see this again later in the semester. We're going to have uncontrollably large numbers sometimes. We're going to have to use mod to bring them back down into a range that's appropriate for our application. So mod 3 gives me 0, 1, or 2, and if I add 1 to it, then that means the range is now 1, 2, or 3, which some people are more comfortable with. Okay, so I'm going to scrape all that off. And store that in a variable. Something like that. So this represents what the computer is randomly selecting to play in a rock, paper, scissors game. Oh, by the way, just one last question just to see if we drove the point home. What if I wanted to sort of use a random number to simulate a 6-sided die where the possible results are 1 pip, 2 pip, 3 pips, and so on? What would the numbers look like there? Nice. Yep, mod 6, which gives me 0 to 5, and then if I add 1, that gives me what a 6-sided die would roll, which is anything between 1 and 6. So mod is great, super powerful operator. You're going to find excuses to use it all the time. When you get a little bit more experience, you're going to find places like, oh, the mod is going to solve my problem here. Super, super cool. Yeah, so nice one, Sloth. It's mod 6. Gives me the range 0 to 5, and then if I add 1 to that, I get the range 1 to 6, and that looks like a 6-sided die. Okay. So I'm going to do a little bit of just sort of my own terminology kind of stuff, just so when I say it, you'll understand it. So I'm not really setting up to implement the entire program, but I wanted you to see the whole story of how the random numbers come to be and how we get the computer to pick something within a desired range randomly. So the next thing that I would say is that you have to take this number and you have to sort of map it, map it to an output. And what I mean by mapping it to an output is basically you just write if statements that say, well, if the number I got back from that random number generator was a 1, I'll say something like the computer picked rock. That's all I mean by mapping. That's really just kind of taking an integer value and using an if statement to turn it into an output that the user can see. If I say the computer picked 1, that's kind of meaningless to a player. So I just use an if statement to say if that number was 1, then I'm going to map that or convert it more or less to an output statement that the user would understand. And then so on from there. Isn't that most of the, I'm going to flip back to the other tab. Is that most of what this thing does? Oh, counters and stuff. I guess I'll give you a couple of hints about that. Okay, so step 1. By the way, you can always do more. So if you want to use functions to organize your code so that it doesn't get crazy long, you're welcome to do that. If you don't want to use functions, you don't have to. It's not a requirement. But if you want to use functions, you can certainly do that to organize the code differently. Okay, so I'll talk about the loop part, and then I think I'm mostly done. So you're going to need, and I'm going to have to move some code around. This is how I would write this. So in C++, we have 3 loops. And what do we want to loop for so that the user can just keep playing, right? Do you want to play again? Do you want to play again? Do you want to play again? We're just going to let them keep playing as long as they want to play. So there's 3 loops that you could use in C++. There's actually 4 you're going to see. There's a variant of the for loop. So I meant the number 4. There's 4 loops. There's 2 kinds of FOR loops. One is a counting loop and the other is a range loop. If you had the Go language, you've seen these before. You may or may not have seen them in C++, but they're there. So there's 2 kinds of FOR loops. There's a while loop and there's a do while loop. Doesn't really matter. I just use while loops for this. You could use a for loop even if you wanted to, although typically I use that for problems where it makes the most sense. You could also use a do while loop here, but I like while loops. Do while loops look messy and they're easy to screw up and get variables in the wrong place. So I just like a while loop. And so normally what I would do is create myself a Boolean variable, which initially the setting about whether or not they're going to keep playing is going to be true because they haven't even started yet. I'm going to move some of this code around in a second. So keep playing is true. You can also, by the way, initialize variables without the equal sign with parentheses instead. I like the way this style looks, so I tend to use it a lot myself, but they're both correct. So totally up to you. And then while keep playing. And then I'll explain what I've done here since we're going pretty fast and efficiently, so I can kind of explain why I'm choosing to do what I did. So this while loop right here. So you notice I didn't put while keep playing equals true. The equals true part is always implied in C++. So if you just say keep playing, C++ assumes that you are implying keep playing is true. You can also, by the way, say not keep playing, in which case you're telling C++ false. So you'll see a lot of C++ programmers not bother with the equals true because it's always implied. Up to you. This one doesn't execute any faster or slower than the other one. You may like it this way because you can more clearly see what's going on, but if you see someone write code like this that says while keep playing, what they're doing is they're just sort of implying true to C++, which allows it. That's how I would write it. And then we're going to have a loop. So inside of this loop, you can have the let the player choose what to play. And I'm not going to write all that code, but the idea there is that you need to prompt them. Use a cout statement to tell the player, pick rock, scissors, or paper. You're probably going to have to give them a little mini menu, like enter 1 for rock, and 2 for paper, and 3 for scissor. Or you could have them type in an R for rock, and a P for paper, and an S for scissor. Or you could have them type the whole word. I never have users type the whole word unless I absolutely have to have it, because they're going to screw that up. So I like numbers and letters when the user has to type stuff, because they're much less likely to screw that up. So let the player choose what to play. Let the computer choose what to play. So that's the code that we just wrote. So I'm going to go grab that. That's this bit right here. That's how the computer picks what to play, is the random number. The players is more elaborate, of course, because you have to ask them to do an input, and then you have to store it somewhere. But I'll point out to you one thing. Since the computer's picking using an integer, because it's a random number, it's a little easier if you have the player also type numbers for their pick. So you might put a prompt that says type 1 for rock, 2 for paper, 3 for scissors, and that makes the comparisons a little bit easier. You might also right here, I would say, then do an output to confirm their play. And what I mean by that is you're going to do this same kind of mapping. So you just played rock, you just played paper, you just played scissors, just like we do with the computer, so that they know what's going on. So I'm going to take this, get rid of the extra empty lines because that looks like crud. So let the computer pick, and then I'm going to use this little mapping setup to print out so the player knows what they picked, because it wouldn't be any fun if it's just like, you lost. Why did I lose? What did they pick? And then you're going to have, of course, else if other stuff, which I'm going to comment just so you know. So notice, other than seeding, everything else is inside the while loop. Seeding should only happen once in any program that uses random numbers, so I almost always just put it right next to where main starts, once and only once, and leave it there. Okay, so then we're going to have a check to see who won down here, which is also going to be if computer rock and human rock, then that's a draw, right? So you're going to have a whole bunch of that kind of stuff down here. And then you're going to say, you played rock. You've already kind of, if you're doing it my way, you've already told them what the computer played, and you've already confirmed for them in an output what they played. So you can just say, you chose rock, the computer chose rock, draw, that kind of thing. All right, so hopefully everyone's followed that. The last thing that I'll give you a hint about is the counters. So what you're supposed to do is keep track of how many times they won, how many, what did I say for counters here? Yeah, count everything. So every time they win, keep count. Every time they lose, keep count. The way you're going to do that is you need to be outside the loop. And the reason why you need to be outside the loop is because the report of the counters is going to happen after the loop. So before the loop even starts, you're going to create wins 0, losses 0, draws 0. Remember, in C++, you got to zero the things out. It's no guarantee that they'll get zeros if you don't make them be 0. So here's my counters. The reason why I'm declaring them way up here at the top I am going to keep count in the loop, but at the end of the program, print out how many wins, losses, draws. I want to print that out after the while loop. So the only way to have access to these counters, both in the while loop and again outside the while loop at the very end, is to declare them way up here. You have to do it. If you declare them in the while loop, then they will be limited in lifetime to the scope of the while loop. So you have to declare them before the while loop starts. You can use them in the while loop, and then you can use them again after the while loop. So this, for example, is going to be draws plus plus. All right, that's most of the programming. Obviously, it's not most of the program, but I think that sort of hopefully leads you to the places that you need to do work. Again, we're kind of boot camping C++, so for almost all of you, this is going to be relatively simple, most of it. I hope that I have described for you the things that may or may not have been new to you or not fresh for you, so that you can sort of jump in here and do this thing. I also, by the way, don't care if you want to put additional options. It's a pain in the rear to do that, to like what comes after rock, paper, and scissors. Spock? I forget. But if you want to do that kind of thing or theme it a little bit differently, that's all fine. The point for me is just to give you an excuse to declare variables, make counters, do outputs, if statements, all that stuff. Lizard. Okay, thank you, Lizard. Oh, and by the way, I don't know if you noticed, but I'm moving this terminal around just so you can see more code. I don't even know if let me see if this will compile. Yeah, but since it's in a loop, it's broke. Oh, let's do that. Way down here at the bottom. We need to prompt them. This is how I usually do it. So do you want to play again? And then we will do a declare a char answer. In this case, we don't really need to give it a value because we're about to read it in. Giving you this whole part for free. Let's be fancier, shall we? So everyone knows, I hope, that the proper way to do this, if you want to be user-friendly, is to make sure that you're checking for both the possibility they typed a little y. In fact, I'm only interested in no, I don't want to play anymore here. Or a big Y, big N. Keep playing is now false. That will cause the loop to break the next time around. But I want to just show you a different way that you could do this, which is the way that I typically do it. Instead of manually checking both, what I do is I use this library function, the standard function called toUpper, and I just uppercase their answer. And then I only have to check for one possibility. So if it was a lowercase n, it gets uppercased. If it's an uppercase n already, it gets left alone. That's how I would typically write it, but it's because I think I can type it faster. So there's the bottom of the loop with the ability to break out. And the reason I did that is because I noticed that this was racing out of control down here. Okay, so yes, yes, yes. Took them a while to pick rock again because remember the random numbers are doing that and I'm only checking for rock. No, and then it's all working. So when you probably know this from the first week, but if you have a program that wants you to type stuff, you click down here in the terminal part and type it. Okay, that's my whole show. Does anybody have any questions I can answer? Thanks for those of you if you're putting up questions on Piazza or answering them. I very much appreciate that because uh, it's just going to help everybody. So I appreciate your efforts to watch the discussion boards and contribute by asking and answering questions. It's great. So thank you. And I'll just sit here for a minute or two and see if there's any questions, and then I will sign off. Up there. There's all of Maine. Okay. Um, Thank you, guys. I appreciate that. Thanks all of you who were able to be here for the live video. Before I go to bed tonight, I will post the video in all the places that I do that. Go ahead, ask the question. Oh, that's interesting that you like C++ better. Um, that's cool. It's C++ is my first love as a language because it's the first one that I got to know sort of inside and out pretty good. So, Sugam, go ahead and ask whenever you want. Okay, no, that's not a dumb question at all. So the question is, if I make a function, let's just say I have a, um, let's say I have a function where I'm going to offload all of the you picked rock, you picked, um, the SRAN still just stays exactly as it is. Even if you're doing random numbers up here, the SRAN still stays exactly where it is and only once. So that's a good question, actually. What happens if I use rand in other places in my program? Nothing to the seeding. It's still only once and in exactly that same place. So that's a good question. Okay, you're welcome. Um, Again, thanks for being here. And if you're watching later, then thanks for watching. I'll post these videos to the lecture page, to the videos page. Remember, I have to go through this routine where I export the video from Twitch over to YouTube, and then I download it, and then I upload it to a captioning service, and I'll do all that tonight so that the video will, in various formats, will be available for everybody. Otherwise, have a good rest of your week, everybody, and I will see you on Tuesday next week at 6 p.m. Again. Um, and it's kind of a weird time. A lot of you were signed up for an evening class, but um, once a week, hopefully, we'll all stay good with it. Thank you, baby doll. Thanks, little peeper. It was fun. Don't hesitate to. Um, Next week, a good thing to do might be to look at the first project, and we can sort of, if we have some time left over, we can jump on to a different REPL and start looking at how do I start the project. Thanks, Tyler. Appreciate it. Anyway, everybody take care, and I'll see you next week.